Hello! So today we're talking about polygons and their angles. So we're going to be talking about interior angles, so inside of the shape, and then also exterior angles or outside of the shape. So the first definition we're going to go over is a polygon. So a polygon is just a closed figure. It's a shape that has at least three sides. So when I say polygon, could have three sides, could have four, could have five, could have 11. Just has at least three sides, the shape. The sum of the interior angles of a polygon depends on how many angles there are. So here is a little table right here and over here. So these tables just tell you how many sides each of these different shapes have. Most of these you'll probably know already, like octagon, pentagon, quadrilateral, triangle. You probably already know those, hexagon. But just in case you see other names of other shapes, you will know how many sides they have based on this chart. If we say n-gon, n-gon just means we don't know how many sides the shape has. It has at least three, but we don't know exactly how many. So triangle obviously has three sides. So if I wanted to make triangles out of all these shapes, this one, it's just one triangle. It's already a triangle for us. And we know from previous lessons that the sum of all the interior angles of a triangle is 180 degrees. At least hopefully we know that. A quadrilateral, that's a shape that has four sides. So if I use this vertex right here and I draw a line to the opposite vertex, I created two different triangles. So I know this triangle, all the interior angles add up to 180. And the same for this triangle. Those all add up to 180 degrees. So the total amount of degrees for this quadrilateral, or any quadrilateral, oh, by the way, there's two triangles. Total amount of degrees would be 360 degrees. Now, a pentagon that has five sides, the number of triangles in a pentagon, as you can see if I start at this vertex and draw a line out to the two opposite vertices, we get three triangles. So each one of those has 180 degrees. So there's three triangles. So I can multiply 180 times 3. I get 540. So the sum of all the interior angles would be 540 degrees. So moving on to the next page. Hexagon. That's 6 sides. Number of triangles, as you can see, is 4. And the sum of all the interior angles would be 180 times 4, which is 720 degrees. So hopefully you start to see a pattern here. So now a heptagon has 7 sides. Number of triangles, 1, 2, 3, 4, 5. The sum of all the interior angles would be 180 times 7. Excuse me, 180 times 5, my fault, which would be 900 degrees. So now we're going to have to see if we can figure out that pattern by filling out this table here. So they name the polygons for us, and then we have to say the number of sides, the number of triangles formed, and then the sum of all their interior angles. So quadrilateral has 4 sides. The number of triangles formed was 2. The sum of all the interior angles is 360 degrees. Pentagon that had 5 sides. There are 3 triangles formed. Oops. And there was 540 degrees when you added up all the interior angles. Hexagon, 6 sides, 4 triangles formed, and 720 degrees on the interior. N-gon, that has n number of sides, so we don't know how many sides, just like a variable. So if you look at all the number of sides, so like quadrilateral, we had 4. There were 2 triangles formed. Pentagon had 5 sides, 3 triangles formed. Hexagon had 6 sides, 4 triangles formed. So hopefully you see that pattern that we're just subtracting the number of sides by 2. So if an n-gon has n sides, to figure out how many triangles are formed, I would just do n minus 2. And then what we're doing to find the interior angles, the sum of all the interior angles, is we're multiplying the number of triangles by 180, because 2 times 180 is 360, 3 times 180 is 540, and so on. So the little formula we have here is n minus 2 times 180. So if we're ever trying to figure out the total sum of all the interior angles, I can take the number of sides, subtract it by 2, and multiply times 180. So I'll write that up here. So n minus 2 times 180 equals total degrees of interior angles. So in example 1, it tells me to find the sum of the measures of the angles of an 18-gon. So 18-gon, obviously that means there's 18 sides. So remember our formula is n minus 2 times 180. So if there's 18 sides, then n is 18. So 18 minus 2 times 180. So do parentheses first. So 16 times 180. And 16 times 180 on the calculator real quick. So that's 2,880 degrees. So in example 2, this time they give us the sum is 1,980. So we got to find the number of sides. So if you remember, n minus 2 times 180 equals the total amount. So this would be my little formula here. So now I just got to solve for n. So divide by 180, didn't mean to write that through the number. So 1980 divided by 180. Oops. 11. So n minus 2 would equal 11. Add 2 to both sides and we get n equals 13. So a 13-sided shape would have 1980 degrees on the interior angles. Example 3. So this time we got to find the measure of angle Q and the measure of angle R. So how many sides does this shape have? Or it's easier for you, can just count the vertices, count each vertex, and there's 4. So if there's 4 sides, if you can't remember it's 360 degrees, you could do this little formula. So 4 minus 2 is 2, times 180 is 360. So there should be 360 total degrees when you add up all the interior angles. So that means if I add 80 plus 70 plus x plus 2x, that has to equal 360. So combine your like terms. Subtract 150 on both sides. So 3x is equal to 210. Whoops, 210. Divide by 3. So x equals 70. So that means the measure of angle Q equals 70 degrees. The measure of angle R is equal to 140 because it's just 2 times x. So on the next page, now we're going to talk about exterior angles. So exterior means on the outside. So exterior angles, so if this was my pentagon here, exterior angles are just when we extend the lines. That'd be like this angle, and so on. So we see all those numbers. So exterior angle sum theorem says that the sum of the measures of the exterior angles of a convex polygon, we're pretty much only going to be using convex polygons, is always 360 degrees. So when I add up all of the exterior angles of a polygon, it's always going to add up to 360 degrees. So in example 4, if these are all my exterior angles here, if I add them all up, so I'll start with x. So x plus 2x plus 2x plus 4x, and then plus 3x. That should equal 360 degrees. So if I combine all the like terms, so 1 plus 2 is 3. So 3x plus 2 is 5x, plus 4 is 9x, plus 3 is 12x. So 12x equals 360 divided by 12. I get x equals 30. So they just asked us to find the value of x, so I'm done with that one. Example 5. So now we see a shape that has all angles that are congruent, all side lengths are congruent. So that is what we call a regular polygon. So if you want to pause the video right now and write down the definition of a regular polygon, that's something you're going to need to know. So a regular polygon is the shape that has all sides congruent and all angles congruent. So if we have a regular polygon, and we extend out each of these sides here. Regular polygons not only have all interior angles congruent, but all exterior angles congruent. So if this exterior angle is x, all these exterior angles are going to be x. So if I wanted to find what x is, I first need to figure out how many sides the shape has. So 1, 2, 3, 4, 5, 6, 7. So there's 7 sides. They should all add up to 360. So if I added 7 x's together, I would get 7x. So 360 has to equal 7x. Divide by 7. And x should be about 51.4 or so. So each of those exterior angles is about 51.4 degrees. In example 6, find the measure of an exterior angle of a regular polygon, or if the measure of an exterior angle of a polygon is 120 degrees, how many sides does the polygon have? So remember, all the exterior angles have to add up to 360. So if one of those angles is 120 and it's a regular polygon, so that means that they're all the same, so all are 120. If I divide 360 by 120, that would tell me the number of sides, which is 3. And then finally, on the last one here, example 7. So find the number of sides for a regular polygon if each exterior angle is 10. So if each exterior angle is 10 and the polygon is a regular polygon, so that means all exterior angles are 10, then I'd have to add up 10 plus 10 plus 10 plus 10 all the way until I get up to 360. Or I could just divide 360 by 10. And that would be 36. So this would have 36 sides. All right, so the last example is kind of tricky, so you really got to be careful when you read these things. Notice that in part B it says each interior angle is 177.5. So if I go back up to one of these shapes here, let's look at this one right here. So notice this was the exterior angle right here, and this is the interior angle. So whenever we have an exterior and an interior angle, they always are on this line right here. And how many degrees is a line? 180 degrees. So whenever I combine the exterior and the interior angles together, they always equal 180. So I don't really care what the interior angle is. I'm trying to figure out the exterior angle. So if the interior angle is 177.5, if I do 180 minus 177.5, that equals 2.5. So now that I know the exterior angles are 2.5, I could do 360 divided by 2.5. And that would tell me that there are 144 sides in that shape. So make sure you notice whether it says exterior or interior.